You're welcome again to our channel. We're doing more examples on the uniform rectilinear acceleration. So today we have a question here that says the body at rest is given an initial uniform acceleration of 8 meters per second squared for 30 seconds, initial, after which the acceleration is reduced to 5 meters per second squared for the next 20 seconds. The body maintains the speed attained for 60 seconds after it was brought to rest in 20 seconds. Draw a velocity time graph. Then find maximum speed attained during the motion, average retardation as the body comes to rest, total distance traveled in the first 50 seconds, and in the same 50 seconds, calculate the average speed. Okay, let's shoot. Now, since we are given the first that happened at rest, so what we'll do is we calculate the velocity attained during that first motion. Okay, so the initial velocity was 0 because started from rest. Initial velocity, the acceleration was 8 meters per second square, and the time was 30 seconds. Beautiful. So we can use first law of motion, v equals u plus at. If you use that, then we can have final velocity is what we are looking for. Initial velocity is 0 plus 8 times 30, which will give us 240 meters per second. That's the first thing we're supposed to do, because it says we need to find that. Okay, now having done that, we can now draw our graph. Now it says a body from rest. Okay, so let's draw a graph. So this is velocity, this is time. Mind you, we have found this to 240. So that is, so it says it starts from rest. When it begins from rest, then after which the acceleration is reduced to 5 seconds. So the acceleration is reduced to 5 seconds. Okay, so it's reduced. Okay, so it's reduced, so it continues. Okay, then it came down. Okay. So after which the acceleration is reduced to 5 seconds for the next 20 seconds. So from the first one is 30 seconds. Don't forget, 30 seconds. Then after that, for another 20 seconds, that's 50. 20 plus 30 is 50. Okay, good. Okay, and the total, and it says attained, the body maintains the speed attained for 60 seconds. 60 plus 50 is 110. 60 plus 50 is 110. Okay, 110. And it was brought to rest in 20 seconds. And you add 20 to this, it becomes 130. Beautiful. 130. So this is time, this is seconds. And the maximum it attained here is the one we calculated here, 240. Okay, meter per second. So, and that's the graph. So it says maximum speed. So we need to calculate, okay, let's calculate that, the speed. So time of deceleration is 20 seconds. Time of deceleration is 20 seconds. Okay, it's 20 seconds. So V, you can now use V, which is 240, V, which is 240, plus minus 5 times 20. Okay, so which will give us 240. You know it's deceleration, so you have to use minus, equals 140. So we now have our 140 here. Okay, good. 140. Beautiful. Okay, so having said that, we can quickly rush over the rest. So now, I've shown you the graph, the maximum speed is 240. Now, I've shown you this graph, the maximum is 240. Okay? Now, the average retardation now will be the average is in that question? Yes. Average retardation. So the average retardation now would be, 140 retardation. This is retardation. So that's 140 minus 0, 0 equals 110 minus 130. Because this is where it retarded, this is where it came to rest. That's retardation. So we are doing 140 minus 0, this minus this. And that gives us 140 over minus 20. Okay, that gives us, so this gives us minus 7 meters per second squared. So therefore, the average retardation is now 7 meters per second squared. The minus is just to show you that it is retarded. Okay, the next one says, number 3 says total distance traveled in the first 50 seconds. Total distance traveled in the first, total distance traveled. So number 3 says total distance traveled in the first, so I told you first 50 seconds. This is the first 50 seconds here. It's just the first 50 seconds here. So the first one is, I told you find the area of the shape. So the first one says half base times height. Half base, you can see it here, this is a triangle. Half base times height, 240 times 30, okay, plus, and here there's a trapezium here, you can see it, there's a trapezium, so that's half into A, which is 240, plus B, which is 140, times the height, which is 20. Beautiful. Okay, so if we do this, it gives us 3,600 plus 3,800, and that will give us 7,400 meters. Okay, so that is the total distance. The total distance covered in the first 50 seconds. In the first 50 seconds. The last question says average speed in the same interval of 50 seconds. Average speed, and since we have the distance, in first 50 seconds, so it's easy. So the distance in first 50 seconds is this. So average speed in the same interval of 50 seconds will now be distance over time, which is 50 seconds. So when I do this, I'll get 148 meters per second. Now I have succeeded in calculating the average speed in the first 50 seconds. I've succeeded in calculating the total distance, in first 50 seconds, and I've succeeded in calculating the average retardation of the body when it comes to rest. And we have succeeded in calculating, in drawing, and finding the maximum speed. Okay, so this solves the problem, and I hope you can relate with this. When you watch the video, you look at it critically, then you get the times. In our next video, we'll continue with our calculations. I'll see you then. Thank you.